Intelliscope heart sound monitor GUI allows close and detailed inspection of recorded heart sounds, giving the doctor the opportunity to revisit what he or she heard. Recorded PCG and ECG signals can be plotted simultaneously by a single click. Then the doctor can slide through the time and focus on a specific set of heart cycles at a time. Pressing the Details button will segment the heart sound and displays S1, S2 and the split between the A2 and P2 components of S2. Again, you can slide through the time and inspect. This allows easy spotting of murmurs in the heart sound. The GUI also provides more graphical data such as A2-P2 split variation over the recording and the systolic and diastolic power percentages.
These are the pre-processing steps that we follow to feed the ECG and PCG signals to the deep learning model. After the denoising steps, we run a local peak detector to the PCG signal and detect the strongest peaks in each heart cycle. So those are marked in red here. Once these peaks are detected, we select a 3.5 second window starting from that main peak. So it is zoomed in the below picture. The same timestamp is taken for the ECG signal, and the same 3.5 second window will be selected for the ECG signal as well. For these two segments of waveforms, we generate the scalograms with the parameters which are described in the full report. Welcome to a quick demonstration of the AI backend that is integrated to Intelliscope. You can see the PCG classification model EL252 that is visualized in 3D. If we feed forward the scalogram that is shown on right, you can see all the feature maps that are generated by the convolutional neural network. So you can see all these connections. For fine details about the training datasets and the procedure, please refer to the full report. Now if we consider the ECG classification model, again, if we feed the scalogram that was generated for the ECG waveform, we can see the feature maps that are generated internally in the CNN. So to see the classification output of the model, we can zoom into the last layer, the 1D output layer, and as you can see, this particular scalogram was generated first classified as abnormal. So if we give an insight to you as to how the hybrid model was built, right now you can see the flattened layer of the PCG model. So when building the hybrid model, we consider these two flattened layers and concatenate them. So now you can see the flattened layer of the ECG model, which is 4800 units. So these two flattened layers are combined so that we can make a hybrid prediction out of the two scalograms. So it should be noted that these two are simultaneous ECG and PCG recordings.